Okay, let's talk about seasoning. Seasoning. Salting. Actually, not really seasoning and not really related to food, but salting in terms of increasing the strength of passwords. Salting involves taking a password and adding additional data to it before you actually calculate the hash of the password in order to increase the strength of that password. So adding data significantly decreases the chance that somebody's going to be able to crack this password. And just understand that by adding different salt values, you create different hash values as a result. So if you look at the table here, if we take a password arbitrarily, just say the password is lock and key, and we have no salt on it, meaning when we calculate the hash value of that using, say, MD5 or SHA-1, what you end up with is some value. If you take lock and key and add a salt to it, in this case our salt is the word sea salt, so our password would actually be lock and key sea salt, and we take the hash value of that, we come up with a different answer, or a different hash value. If we change the salt value and do the calculation again, so in this case, the last column, we have lock and key table salt, and we hash that entire word, we come up with a different value. So what you have here is a way to increase the cryptographic strength of a password by using some predetermined value as part of in addition to whatever password the user supplied. So security considerations of this, salts make plain text passwords longer. Longer passwords are better because they're harder to crack. This is good when you can use random salts. The problem is when you use a known salt value for your password, it's like not having any at all. So using a different salt value for each password or for each user means that an attacker has to know my password and they have to know my salt value in order to crack my password or come up with a hash value for it. And that is significantly harder than if they just had to create the hash value from my password. The comment here, salting can defeat rainbow table attacks. Well, this is true because what is a rainbow table? A rainbow table is the pre-computed hashes of every single letter, character, number, symbol combination out there for certain password schemes like the Windows password scheme. So if the salt value does not change and it's known, you can create a rainbow table or a lookup table, pre-compute all the hashes for it, and you can crack passwords in a matter of minutes. When you have salts that change, rainbow table computations become impossibly complex because I have to have one rainbow table for each salt value. And that is a very, very difficult thing to do. So why doesn't everybody implement salts in their applications? Well, one, not all the application developers out there know about it. Two, it adds a layer of complexity because now instead of just having to know what the password is, I also have to keep track of the salt value for it in order to calculate the MD5 hash. And so not everything uses salts out there. The last point I'll make on this is that it's important to know that you can't use a common salt for everything. And I say this because the salt is only as good as long as nobody knows what it is. Now, you can use a salt value of a username, of the current date and time. That's fine. But if that algorithm to create that salt gets compromised, then the complexity that the salt adds to your passwords is totally irrelevant. And so the salt value, it's good to have it in there, but you need to make sure that the algorithm for calculating the salt value remains a secret as well.